Okay, it's recording. I think I had it recorded anyway. Okay. So I'm going to write example one. I'm right here. I'm going to write example one in vertex format. Okay, so remember, vertex format is A times x minus h squared plus k. All right. Now, here's where h and k come in. H and k is exactly the same as x and y of your vertex. They can't use x and y because if they did, it would be x minus x squared plus y, which means you'd have 0 squared. So that's why they cannot use x and y to get the vertex format. They had to switch up the variables, but it means the same thing. Okay, so in my case, my vertex is -1, 1. So I'm going to write it. My A is -4. So I just repeat it. X minus a -1 squared plus my k value, my y value. And then I just clean it up. So it's -4 times x plus 1 squared plus 1. Now, what you will notice, and this is my vertex format, what you'll notice is inside the parentheses, your x value is always going to be opposite what it actually is as the vertex, because it's x minus whatever your x value is. Okay. So when you're doing so I'm going to do just that part on this one. Okay. So when you're doing your functions, right, you're doing your MyMathLab, this is how you're going to do it. You're going to start with, let me get my pen here. You're going to start with, okay, I have it in standard form. Even though it says A, do the intercepts, B, find the vertex, you're not going to do it in that order because it wants you to write it in vertex format. So you have to find the vertex first. So my vertex, I'm using the vertex formula. So -4 over 2 times A. So remember, if there's no number there, it's a 1. So I have 4 over 2 is 2. So that's my x value. To get my y value, I'm going to plug that answer back into the original equation. So I have 2 squared minus 4 times 2 plus 3. So 2 squared is 4. -4 times 2 is -8 plus 3. So I have -4 plus 3 is -1. Okay, so I can write it. So I have the A is 1, so I don't have to put anything in the front. X minus 2 squared minus 1. And that is in vertex format. Okay, so that's what I would type. It's going to change. It's going to change on me if I type anything into it, so I won't type it. But that's what's going to go. That's how you're going to answer that very first one. Okay. All right, so let me stop there. Any questions on the vertex format or vertex formula? So don't get them mixed up.
So we do the vertex formula first, and then we do the vertex format, right?
Correct. Yes. Okay. So the vertex formula will lead you to the vertex format. Okay. So you cannot do the format unless you do the formula.
Okay. Yeah.
Okay. Okay. Any other questions? Okay. So let's go back to, oh, how do I get out of here? There it is. Okay. So we have our vertex format. We got our vertex. Now we can do everything else. Okay. So I rewrote what was in the in that chart that gives you all that information on how to find intercepts, excuse me, in max or min. So I can answer this question really quickly. I have a -A. What that means is my parabola is going to look like that because it's negative. It's a sad parabola. So is it a maximum or a minimum?
Max.
Good. It's a maximum. Okay, so I can answer that question super quickly just by looking at that very first term. All right, so now here is where the real work comes in. The x-intercepts is where you really have to dig deep, and you're going to do a lot of work on those. Okay, the vertex formula isn't too bad. It's just making sure you remember to use the vertex formula. The x-intercepts is where things get a little tricky, because the x-intercepts are found by factoring or the quadratic formula. Okay, so you have to know how to factor, or you have to know how to use the quadratic formula. Now, if you don't like factoring, or you're not it's not very smooth for you, then just use a quadratic formula. It'll work every single time. It just takes a lot more calculations is all. Okay, so since 12, 62. Okay, so this one, I'm going to do it both ways, so you can see that you'll get the same answer both ways. So with example 1, if I'm doing my intercepts, I'm going to move this over here. I didn't leave myself enough room. All right, so I'm looking for my x-intercepts. And then I'm going to move this over so I can. Okay, let me move it over so I have more room. Okay, so I'm looking for my x-intercepts. So again, x-intercepts is by factoring or by the quadratic formula. Okay, so if I try factoring, remember I have a number bigger than 1, so I'm going to use the AC method, right? So -4 times -3 is 12. I want something that when I add, I get -8. So I'm going to use, so Franco, keep me honest here. So I have -4x squared here, and I have -3 here. So factors that when I add, I get +12. I'm sorry, when I multiply, I get +12, and add, I get -8. I can use -6 and -2. -6 times -2 is +12. -6 plus -2 gives me -8. So I have -6x and -2x. Okay, so what times what gives me a 4? I can have 2x and -2. Oh, yeah, it is -4. Okay, that gives me, 2x. That gives me -4x squared. What do I multiply -2x to get -2x? It's a +1. What do I multiply the 2x by to get -6x is -3. And -3 times 1 is -3. So factoring, I'm going to get 2x plus 1 and -2x minus 3 equals 0. Okay, so remember, the goal is to find my x-intercepts. In other words, what is the x going to be? So that's why I have to set it to 0. And what I'm doing is, if you remember, let me go back over here. Your x-intercept is x when y is 0. So that's why I set it to 0, because I'm saying that my y value is 0. So now I can solve. So I have 2x plus 1 equals 0 and -2x minus 3 equals 0. So now I'm just solving. And this is another part of algebra that you need to be super, super comfortable with. You should never even have to think twice about solving an equation, especially a linear equation. So here I'm going to add 3 to both sides. And I get a -3/2. So these are my two x-intercepts. Okay, so now let's see if the same thing, if I get the exact same thing when I do the quadratic equation. Okay, so the quadratic equation is -b plus or minus the square root of b squared minus 4ac all over 2a. So, and I know this should be somewhat familiar to you because you should have seen it, you know, at least in high school, you should have seen it. I know we haven't talked about it a lot in here until this section, so this may be new to some of you. Okay, so we have our A is -4, B is -8, and C is -3. So all I'm going to do is just plug those into this formula. So I have x equals -b plus or minus, and that's where the two answers come in. It's always plus or minus. -8 squared minus 4 times -4 times -3, all over 2 times -4. Okay, so the quadratic formula works. It works every time. It's just a lot of calculations. So you have to be careful with your positives and your negatives and don't let it throw you. So I just say clean it up, right? So a -8 is a +8. I always get the value underneath the radical. Think of that radical as like parentheses. So -8 squared is 64. And then here's how I do this. I go 4 times 3 is 48. I have 3 negatives. That's an odd number. So it makes it a -48. So you literally just multiply the 3 values, count your negatives. If it's an odd number of negatives, that value is negative. If it's an even number of negatives, that value is positive. And then all over -8. So I just keep going. I just keep breaking it down. So 64 minus 48 is 16 over -8. And so now I have 2 answers. Square root of 16 is 4. So I have 8 plus 4 over -8, and I have 8 minus 4 over -8. So with the quadratic equation and a quadratic formula, you'll always have 2 answers. So here I have 12 over -8, which is a -3/2, just divided both by 4. And then 8 minus 4 is 4 over -8, which is a -1/2. Exactly the same answers. So again, you can decide if it can be factored and you're good at factoring, just factor it. If it can't be factored, then you have to use the quadratic formula. So you have to be comfortable with the quadratic formula. Okay. All right. Any questions so far? All right. So I'm expecting 100% on this section, and I'm going to open it up to have unlimited access so that you can go in and you can practice and practice and practice and practice some more. Because this is one of the sections that's going to be super important. The other 2 super important sections are going to be 2.5 and 2.6. So yeah. All right. So we have x equals -1/2 and -3/2. Those are our intercepts. And then the y-intercept is super easy. The y-intercept, let me get a different color, is when your x value is 0. So that makes it really easy. This goes to 0, this goes to 0, this goes to 0. So your y-intercept is always sitting right there. So it's at the point 0, -3. That's your y-intercept. Okay, so the y-intercept, I'll make it even better for you. The y-intercept is at 0c. That's another way to find the y-intercept because the x is always 0, so it just dumps to 0. Okay, and then you got to graph it. Okay, now in my math lab, let me double check. In my math lab, I don't think they have graphs for you. so that you can expand them. So make sure, don't try and read it off of that, because it's gonna kill your eyes. You can use this bottom button right here. It's a box with an arrow, and you can make it bigger. So when there's a graph, you're just looking at it. So like on this one, you can see that the vertex is at +1, +4. There's your vertex. The x-intercepts are at 3, 0 and -1, 0. And the y-intercept is at 0, what is that? 1, 2, 3. So you're literally just looking at the graph and then identifying all the parts to it. That's all you have to do when they give you a graph. With this one, and I'll show you how to do it in the vertex format. It's a little bit different than the standard format, but it's still pretty easy. So this one, you have to find the intercepts, you have to find the vertex. So you're doing the exact same thing that we did on this one. Yeah, on this one. It just looks different, but you're still looking for intercepts, vertex, max, min, and then the range. Okay. All right. So with this one, I didn't give the range, because you are going to need the range. So remember, the range is all based on the vertex. So if you notice, the y value is the highest point because we have a maximum. So our range goes from -infinity to 1, and it includes the 1. Okay, so when you're graphing these, always graph your vertex first. So there's our vertex, -1, 1. Graph your intercepts. So at -1/2 and -3/2, which is -1.5. And then the y value, or the y-intercept, crosses right here. So there is, oh, that's a straight line. There is your parabola. And there's something called the axis of symmetry, and we don't talk a lot about it, but a parabola is symmetrical. Okay, so if I have a point 1 step away from 0, or 1 step away from the axis of symmetry here, I'm going to have another point 1 step away. So it's going to be symmetrical. It's going to have that mirror image quality about it. Okay, so the axis of symmetry just flows right through, straight down, a vertical line straight down through the vertex. Okay. All right, let's do one more like that, and then I'll switch formats and show you how to do it when it's given to you in vertex format. Okay, so in example 2, now if you notice example 2, now we're dealing with decimals, same concept. The math doesn't change. Doesn't matter what kind of numbers you have, the math doesn't change. So with the vertex, you're going to find the vertex first. So -b divided by 2 times a. So -0.75 divided by 2 times 0.5. Which is a -0.75. So there's my x value. And now I got to find the y value. So the y value is, I plug it all back in to my original, 0.75, original function. Okay. And this is where I'll write it down just so that you guys know that your calculators are doing the same thing. Right. So my y value is negative 4.156. Just double checking something. Yeah. Okay. So there's my vertex. So notice I just did the exact same thing that I did first. I found my x value by using the vertex formula, negative b over 2 times a. And then I took that value and I plugged it back into the original function. Okay, and it's just calculations. That's all it is. It's being able to use your calculator, doing order of operations. Okay, and then for this one, to write it in vertex format, a is the value in front of your x squared, and then it's going to be x minus a negative 0.75 squared, and then minus 4.15625. So then I'm going to clean it up. And my math lab, if there is a decimal, it'll tell you to round it to a certain value. So make sure you look at that. Okay. So don't let the decimals throw you.
Miss, I have a question real
Okay.
quick. So in the formula for vertex formats, there's a H. Do we not like have something for the H that we put inside?
So remember, your H and K is the same as your X and Y.
Oh, okay.
Yeah. H and K is the same as your X and Y. Okay.
Yeah.
And again, you can't use the reason why they had to throw that in there as H and K is because if I used X, right, it would be X minus X squared, which becomes 0. So that's why it wouldn't work. So that's why they had to come up with the formula using H and K.
Okay, thank you.
Okay. All right. So we have our vertex format. We have our vertex. And now we're going to find our x-intercepts. So with this one, I'm not even going to try to factor it, right? Because of the decimals, I'm not even going to try. So I'm going to just use my vertex formula. I'm sorry, my quadratic formula, all these formulas, my quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, and that's all underneath the radical, all divided by 2 times a. I'm going to move over. Okay, so now it's just a matter of calculating. So again, order of operations, I'm going to find what's underneath my radical first. And then I'm going to do 4 times 0.5 times 5 is 10. And if you look, I have 2 negatives, which makes this a positive. So again, all I did is I did 4 times 0.5 times 5, and then I count my negatives. I have 2 of them. That's an even number. It's an even number, so I know it's a positive. And 2 times 0.5 is just 1. So 0.75, it's a negative 0.75, plus or minus the square root of 10.5625. Okay, and over 1, I don't even need it. Okay, because anything over 1 is just the top. So now I have 2 answers. I have negative 0.75 plus the square root of 10.5625, and I have negative 0.75 minus the square root of 10.5625. So now I'm just going to calculate it. Negative 0.75 plus the square root of 10.5625. So this one I get 2.5. And this is where you got to learn to use your calculator, and -4. So those are my two x-intercepts, 2.5 and -4. And then again, my y-intercept is easy. It's just 0, -5. That's the point where it crosses. Max or min. So this one is a positive, right? My first number is positive. So that means I have a minimum. And then the range is always based on your y value of the vertex. So because it's a minimum, it goes from -4.15625 to infinity, because it's going up forever. Okay. And then I'll graph it. So -0.75 is -3/4, and then down 4 and a little bit. There's my vertex. My x-intercept is at 2.5 and -4. My y-intercept is at, okay, what did I miscalculate? So here is a great example of how do you know if you're doing something right or wrong. So my y-intercept is at -5. 1, 2, 3, 4, 5. So that's here. Do you see how my vertex is higher? So there's something wrong with my vertex, right? Because my parabola should cross through that y-intercept and hit here. And it should come down and hit here. So my vertex needs to be down here someplace. Okay, so let me double check that. Did anybody else get a different vertex? You guys are just going to leave me hanging? Okay, so that first number is right. Ah, I just saw it. I think. Haha, yep. Okay, so do you see how I have right here? I have a -0.75, and here I have a positive 0.75. You guys are supposed to catch me. You're supposed to keep me honest. So this is a negative here. So that's why. So it is 0.28125 minus 0.5625 minus 5. There it is. See, if you guys were paying attention, you would have caught that. You're supposed to keep me honest. There it is. Okay, so this is actually a great example. That's why knowing that your parabola is symmetrical, right? If I know that my 1, 2, 3, 4, if I know that my y-intercept crosses here, my vertex has to be below that because it's going up. So my vertex is at -0.75 and 5 down here someplace. Now it's right. And do you see how it's symmetrical, right? It's a mirror image across that axis of symmetry. Okay. So mistakes can be made easily when you're doing all this calculations. Very, very easily. So that's why when you graph it, it should always be symmetrical. Okay. All right. Let's look at one more in my math lab, because it's going to look a little bit differently. So let's do this one. Okay, so and then after this we'll take a break. Okay, so see how this one is in vertex format, right? It's in vertex format already. So you're going to do the exact same thing. You're going to find all the same things, but now you're looking at it in vertex format. So when it's in vertex format, the vertex is sitting right here. That's that H and K. So the vertex, so when it's in vertex format, the vertex is much easier to find. So remember, it's the opposite of the X value and the same of the Y value. There's your vertex. Okay. The intercepts, this is where you have to know where the intercepts lie. So the X-intercept is at X0, and the Y-intercept is sitting at 0Y. So what this tells you is if you're looking for the X-intercept, you have to replace the Y with 0. If you're looking for the Y-intercept, you have to replace the X with 0. So we'll just do it in the same order. It's looking for the Y-intercept. So on this one, I'm replacing the X with 0. So my Y-intercept, I'm going to go 0 minus 7 squared minus 1. Okay, so all I did is I took my X value and I replaced it with 0. So now I can calculate. So negative 7 squared is 49 minus 1. So my Y-intercept is at 48. Okay, I'm going to show it complete so we can get through these. And it changed the values. It always does that. Okay, I'll just do it again. Okay, so it changed the values. So again, to find my Y-intercept, oh, let me scroll up. Don't change. Okay. Okay, so again, it's in vertex format. I'm looking for my Y-intercept. So I'm replacing the X with 0 and then calculating. So negative 3 squared minus 6 is 9 minus 6, which is 3, and there's my Y-intercept. Okay, so Y-intercept, you replace the X with 0. To find the X-intercepts, you replace the Y with 0. So remember, this is another way to say Y. So it's 0 equals X minus 3 squared minus 6. Okay, so now I have the only variable I'm looking for is my X. So I have to calculate, right? So this is solving for X. So I'm going to add 6 to both sides. So I get 6 equals X minus 3 squared. And then anytime you have something squared, in order to get rid of it, you're going to do inverse operations. So you're going to square root it. So what that does is it goes back to this idea. This undoes this. And so this makes that go away. So all I have left is what's underneath the radical. Okay, so I end up with the square root of 6 equals X minus 3, because the square root undoes the squared. So when you have square root, when you square root, that's where the two answers come from, plus or minus. So anytime you square root, you got to do plus or minus. And then I'm going to add 3 to both sides. Running out of room. All right, so I have X equals 3 plus the square root of 6, and X equals 3 minus the square root of 6. And then you just calculate it. And make sure it's in the right format. So this is where they get their 5.4, and they're rounding it. And then the other one is 0.55. So notice when it says rounded to 2 decimal places. Okay. So the intercepts, you're just replacing one with 0 and then replacing the other with 0. And then my vertex is sitting right here. The vertex is at 3, -6. It's sitting right there. Is it a max or a min? Well, my first term is positive, so it's a minimum. And then the range is based on the y value of my vertex. So the range goes from -6 to infinity. It goes up. Okay, and let me just double check. Are they making you? Okay, so they're asking you, you can type it either as an inequality or as interval notation. So interval notation is the way I wrote it, from -6 to infinity, or you can write it x or y is greater than -6. Same thing, or same message, I guess I should say. Okay. All right. Any questions so far? We'll do several more of these when we come back. All right. I'm going to clear all this. You guys take your break, rest your brain, because when we come back, we're going to jump back in. And then, so come back at 1/4 after. Be able to see. There you are. Okay, I'm back to recording. You guys have to remind me. Franco, that's your job. Remind me if when I start that I get set it to recording. I didn't record the last class. Okay, so before we get started, let me share my screen again. I just want to make sure, because you guys are awfully quiet today, and I know it's that time of the year where it's hard to be motivated. And I know it's always one of those, it's like a shock to the system where you're in the middle of something and you can see the end, and Thanksgiving's coming and we haven't had a break in forever. So hang in there, you guys. It'll be over soon. We literally, after this week, let's see, after this week, we have 1 full week and then Thanksgiving. And then we have 2 full weeks and then finals. So we literally have 1, 2, 3, 4, 5. We have 5 weeks and then finals. So it's going to go so fast. Before you know it, the end is going to be here and you're going to go, oh my gosh, what happened to the last 16 weeks? It's incredible to me how fast it goes. Okay. So any questions before we move on? Not one. All of you guys are like, completely understand it. Got it. All right. I'm moving on. Okay. So now we're looking at some word problems, right? So now we've got to apply what you just learned. So whenever you're doing these, I want you to put some terminology together. Okay, this is going to be key in you being able to walk through any word problem. You have to be able to put the terminology together. So when you're looking for break-even points, okay, so a break-even point is here and here. So what we have here is we have the parabola is the revenue function, okay? And the line is the cost function. The break-even points are when the revenue and the cost are equal. And we talked about that on Tuesday. So break-even is you will hear that term a bunch. That is when the revenue and the cost are equal. So as you know, when something is equal, they cross each other. So that's where these two lines or these two graphs are crossing, is at the break-even points. So when you're looking for break-even points, what you're looking for is you are looking for the x-intercepts, right? That's what you're actually looking for, is the break-even points are the x-intercepts. So how do you find the x-intercepts? You find them by factoring or the quadratic formula. Okay, that's how you find break-even points. To find the vertex, I'm sorry, let me do it differently because we're looking at terminology. To find the maximum or the minimum, you find the vertex. How do you find the vertex? You use the vertex formula. Okay, so that's those two terms are going to be super, super important. When you're looking for break-even points, what are you looking for? You're looking for the x-intercepts. How do you do it? You do it by factoring your quadratic formula. If you're looking for the maximum or the minimum, you find the vertex. How do you find the vertex? You use the vertex formula. Okay, so those two things are going to be key in being able to get through any of these word problems. So here we go. A company sells notebook computers, has the following revenue and cost functions. Remember, revenue is the number, do it over here. Revenue is the number of products times the price. So that's what you have here. X is the number of products. 2,000 minus 60X is the price. So you're going to distribute that. So you have 2,000X minus 60X squared. So your revenue function, and I'm just rewriting it, putting it in descending order, right? So descending order means the exponents go down. So notice the revenue is your x squared. That's your quadratic function. Okay, so that's going to be key. You're going to go, oh, it's a quadratic. I know how to do quadratic functions. I can find the vertex. I can find the max or min. I can find the break-even points, which are the x-intercepts, and I can find the y-intercepts. All right, the cost function is linear. How do you know? Because your x is to the first power. All right. The other thing to notice when you're doing word problems is always identify what the variables represent. So in this case, the x is thousands of computers. So it's the number of products. Remember, x is always, it's always in the form, the number of products and the dollar amount. Okay, your x and your y. And the cost and the revenue are in thousands of dollars. So those are going to be important pieces of information, because if you get an answer like 3, you're not going to go, oh, I need 3 notebook computers. No, you need 3,000 notebook computers because X is in thousands. Okay. And then both functions have the domain. Remember, domain are the X values between 1 and 25. Again, this means 1,000 up to 25,000 because again, X is in thousands. So whatever the number is, you just multiply it. And so 1 times 1,000 is 1,000, 25 times 1,000 is 25,000. Okay, so then you're going to sketch a graph. So here's our sketch. We've already sketched it. The best way to do this is you just plug values into your function. So if I wanted to sketch my revenue function, so if I was looking for my revenue function, I know my X value can be between 1 and 25, right? So I can have, any values I want. This is one way. So you plug your 1 in, to your revenue function and you get out an answer. You plug your 5 in, and you get out an answer. And then you can plot points. That's one way to do it. The other way is you find the vertex, you find the x-intercepts, and you'll be able to plot your points. Okay, so there's a couple different ways to do it. Another way, and this is not, I don't want you to do this as a cheater. This isn't a cheater way to do it. This just helps you to know whether your answers are correct. Okay, so if I type in, it was negative 60x squared plus, oh shoot, what was it? 2000x, there it is. Plus 2000x. Okay, now obviously this is that Desmos.com calculator. It's a graphing calculator. Those numbers are very large, right? So I'm going to adjust because we only want it in positives. I'm going to say that it's going to be in steps of 1,000. That'll make it a little easier. And then my y-axis, this right here is probably the hardest part. And then up to, oh, let's see, 20,000. And steps of 1,000. Oops. Okay, so now it's a little bit easier to look at. Okay, I adjusted it so that I can actually see it. Now, here is the beauty of Desmos. But please, 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 when you are doing these, do not let Desmos give you the answers. You want to do the math, like find the vertex, and then double check to make sure that Desmos or that your answers are correct. Okay, so let me show you what I mean by that. So here's my function, right? I'm going to find the vertex. So negative b over 2 times a. So I get negative 2,000 over negative 120. So I'm going to calculate this. Is 16.667. Okay. Yes. All right. So let's look. Watch what I can do with this Desmos. I bring my cursor and I put it at my vertex. Do you see it? Look at there. So your vertex calculated is the same as the Desmos picture. That tells me, okay, I calculated it correctly. So now, so this is my x value of my vertex. So now to find my y value, so there's my x value. To find my y value, I'm going to plug that answer back in. And then again, I'm going to calculate it. So I'm using my calculator. So 16.667 squared times negative 60. And I get a negative 1667.33, oops, plus 2,000 times 16.667. And I get 16666.67, and I'm just rounding it. Well, look, when I go back to my graph, my answers match. What I don't want you to do, and this is going to be, it's going to be very, very clear on your next test if you do this. If you just give me the answers, I'll know that you just used Desmos, and I'll take points off, right? If you show me your calculations, then I'll give you full credit for it. Okay, so make sure that whenever you use technology needs to verify that your math was correct. It should never be the other way around. Technology should never be the way that you find the answer. You should make sure that your math is correct, and you can verify it using technology. Okay, is that clear to everybody? What I'm asking for? Because I am giving you a tool to use, right? I am giving you a tool to use, but it's a tool to use in a very specific way. And what happens is, and this is very true ever since even before the pandemic, but especially since the pandemic, is we have found a lot of students just cheat their way through. They have no idea what they're doing. All they know is they know how to use technology. So technology can be a detriment to you, because if I asked you, well, how did you find the vertex? You would have to be honest and say, well, I use technology. So that tells me you don't know what you're doing. So please, please, please make sure that you are using the technology correctly. And then prove it by making sure that your math matches what the technology shows. Okay? All right, so that's one way to check your work, to make sure that you're doing the calculations correctly. So back to the word problem. We have, our revenue, we have our cost, and now we want to find our break-even points. Okay, so remember, the break-even points is when the revenue equals the cost, right? Revenue equals the cost. So we're going to do our revenue equals the cost function. Okay, so we have to make sure that we put everything to the left side, right? We want to make sure that we subtract off the 4,000, 4,000, not 40,000, and subtract off the 500x. So we get negative 60x squared plus 1,500x minus 4,000 equals 0. Okay, so when you find your break-even points, your revenue is going to equal the cost and then set to 0. Okay, that's one way to look at it. Here's the other way to look at it, is between the break-even points, so all of this, all the way up to the other break-even points, this is all profit, because it's everything above the cost function. It's all profit. So another way to find profit, or the break-even points, is your revenue minus your cost. Either way works. Either way, you'll get the exact same answer. So if I did the revenue, if I was looking for profit and I said my revenue minus my cost, where am I? Minus my cost, you can see I'm going to get the exact same thing. So 200x minus 500x is 1,500x, and then minus the 4,000. So either way works. It's either revenue minus cost or it's revenue equals cost. Either way works. You just decide which way you want to see it. And that's all that this is all break even. So when you hear the term break even, you're making sure you're looking to see where is the revenue and the cost equal, or where's the profit start and stop. Because that's what these break even points is, when your profit starts. It starts here and it ends here. Okay. Anything before that point, the first point, so down here is a loss. Anything after the second point is also a loss. Okay, so profit is very specific between two values. Okay, all right, so now we have a function, right? We have this break-even point function, and it's also a profit function. So we're going to find our x values, because that's how you find break even. And so instead of me doing it, I'm trying to save myself some time. Instead of me doing it, I used my quadratic formula. So that's what this is. So that's where they got all those numbers. Okay. And so the company breaks even at 3.035 thousand computers. So again, multiply that by 1,000. So 3,035 computers and 21,965 computers. So that's where your profit starts and stops. And then the loss occurs below that. So in your My Math Lab, it's going to ask, where does the profit happen and where does the loss happen? So the loss happens below the cost line and the profit happens above the cost line. Okay, so that all is all talking about the same thing, break even, blah, blah, blah. Okay, here we go. So here's another one, another type of word problem. In fact, let me go to the actual homework so you can see what types of word problems you have. So you can see on this one, and again, you guys will have different numbers, different values, but the process is the same. So they give you a price. Remember, we talked about all those different functions. They give you a price. They're asking you to find the revenue. So they went the number of products times the price. So here is your revenue function, is 80x minus 3x squared. There's your revenue function. Okay. And then again, notice the X represents millions of chips and the revenue represents millions of dollars. Okay. And your domain is between 1 and 16. So they're having you look at these graphs. Now, here's a little trick. So you see you have your revenue function, right? When you look at this one, if you look at how, if I rewrote it in descending order, remember how we talked about the first term being positive or negative? Well, because your first term is negative, you actually have a maximum, right? So look at your three graphs. This one is out because that's showing a minimum. Okay. Now look at the other two remaining. Do you see B? Look at these numbers right here. Those are negative values. You can't have negative revenue. It doesn't make any sense at all. This is saying when you have negative 10 products, you have a revenue of 50,000 or 500,000. So that one has to be out. So your only answer can be this one. So sometimes you don't even have to graph it. Sometimes you can just look at the graphs and logically walk it through. You know you're dealing with a maximum. You know you're dealing with a parabola that opens down. So that knocks out C. You also know with revenue, you can't have negative values. So that knocks out B. So the only answer is A. Okay, so sometimes if you just think logically through, it'll make more sense. Okay, so here's the keys. More terminology that will make your life easy. When you see the term maximum revenue, think vertex. When it asks for the output, this is the X term of your vertex, right? The number of products. That's what it's asking for. How many products do I need to get maximum revenue? So we go back to our revenue function. Okay, our revenue function, and we find our vertex. Negative B over 2 times A. So negative 80 over negative 6. So notice it says type an integer or a fraction. Integers are not decimals. Integers are either whole numbers or a fraction. So what they want is for you to leave it as a simplified fraction. That's where the 40 over 3 comes in. Okay. Then when it says what is the maximum value, this is the Y term of the vertex. So you're going to take that 40 over 3 and you're going to plug that back into your original equation and calculate. So we have negative 3 times 1600 over 9 plus 3200 over 3. All I'm doing is I'm just multiplying. 40 times 40 is 1600. 3 times 3 is 9. So now I can just calculate. So negative 3 times 1600 divided by 9. So this value is negative 533.33. And then 3,200 divided by 3 is 1066.67. So that's where they get this value. So they did 1,066.67 minus 533.33, and they get 533 million. Okay. So if it's looking, if it's asking for the number of products of a maximum, you're looking for the X term of the vertex. If it's looking for the actual value, whether it's revenue, profit, whatever it is, you're going to find the Y value. Okay. Any questions on that? Okay. All right. So now what we're going to do is I'm going to skip. Okay. Now I'm going to go and I'm going to do real quick 2.4. Okay. So quadratics, we're good. All right. With polynomials, and like I said, I X'd out a whole bunch of stuff. So here's, I'm gonna do this as fast as possible, but as clear as possible. So degree of a polynomial. The degree of the polynomial is the, not first, it's the highest exponent. That's the degree of a polynomial. So in this case, your highest exponent is 3. So it's a third degree polynomial. If something is already factored, you count the exponents on the outside. So 1, 2, 3. That's how you find the highest exponent. If I had a polynomial that looked like this, like that, all I do is I add the exponents. So this is a 3, 5, 7. This is a 7th degree polynomial. It's as simple as that. Okay, if it's factored, you just add the exponents. If it's not factored, you find the highest exponent. That's the degree. Okay. Let's see, we got that. Okay, in behavior. So I'm gonna break this up super easy. If it's an even degree, so I have x squared, x to the 4th, x to the 6th, x to the any even exponent. When we're talking about end behavior, we're talking about what's happening at the ends of the graph. Okay, so if I have a even degreed polynomial, you have your end behavior goes up, or down. The difference is if they're both up, it's a positive first term. If it's down, it's a negative first term. Okay, so let me take you back to Desmos. You see how this particular function, it's a negative 60x squared. So my highest exponent is even. And you see how it's going down because my first term is negative. If I had x to the 6th, x raised to the 6th power, these are both going up because my highest exponent is even. Simple as that. Even exponent, it's either up or down. If they're both up, your first term is positive. If they're both down, your first term is negative. Okay. If you have, let me get back to here. If you have odd, so this one, so let's finish the even. This even is x to the 4th. It's positive. So it is my end behavior is going up. Okay. If I have odd degree, 3, x to the 3rd, even x to the 1st, x to the 7th, x to the 5th, x to any odd exponent. You're going to have one of two options. It's going to go up and then down, or it's going to go down and then up. How do you know the difference? This one, when it's ending down, it's ending in the negative direction. If it's ending up, it's ending in a positive direction. Okay, so back to Desmos, let me show you. If I had x raised to the 3rd power, you can see it's positive and it's ending on a positive note. So it goes down and then up. So think odd opposite. Odd, you will always have opposite directions. If I throw a negative on here, see how it switches? So we have still going in opposite directions, but it's ending in a negative note because my first term is negative. And these are just characteristics of every type of function that we have. It doesn't matter how big our exponents are. Okay, so this one is positive. So it ends on a positive note. So it begins going down and it ends on a positive note. Okay, and then turning points is just how many times it switches, direction. So this one, we have a 2, 3, 4th degree polynomial, which means it's even. Okay, it means it's even, and it has at most 4 minus 1 turning points. So it has at most 3 turning points. Okay, so since it's positive, I know I'm going to have it up, up, and it's going to turn at most 3 times. So it's going to look something like this. It's 1, 2, 3, and it goes up again. So it's just this is so superficial and so basic that I don't want to spend a whole lot of time on it. All right, I'll show you in my math lab what it all means. Okay, so blah, 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 we're skipping all that. All right, so you're going to see a couple word problems. Here are the 2 that you need to worry about. The first one is average. So average is shown with a bar. So it's the cost with a bar over it. That's how it shows average. And so you know how if I told you to find the average test score, you would add up all your tests and then divide by the number of numbers? That's all you're doing here. You're going to take the total cost. So here's our cost function. And you're going to divide by x. That's it. And we can simplify, right? You can write that x under both terms. So I can simplify even further. So I got 240x divided by x, so those x's cancel, plus 300 over x. Or I can write it as 240 plus 300x to the negative 1. So remember, negative exponent just says flip it over. Okay, so you're just, and in my math lab, it actually gives you this. It actually tells you how to do it. So if you're looking at an average, you just divide by the number of products, which is always dividing by x. So when you're looking for what's the cost when you have 600 surfboards, so again, 600 is the number of products. So our average cost at 600, we're going to go 240 plus 300 divided by 600. So 240 plus half. So the cost is $240.50. That's it. Okay. And then what does it tend towards? It tends towards the 240. So it's going to hover around the 240. So whatever that whole number is. Okay. So let me show you. I know I'm running out of time. I want to show you a couple of the questions on oh darn it. Yes. Hang on. Let me get to it. There it is. Okay, so do you see it? All it's asking for is the degree of the polynomial. You look at your highest exponent, and at this case, it's just a 1. And then it's asking for x-intercepts. Well, you guys already know how to do x-intercepts. X-intercepts is when the y is 0. So it's 0 equals 5x plus 4. Subtract 4. You have 5x equals negative 4. So x equals negative 4/5. That's your x-intercept. And then the y-intercept is when your x is 0. So you go 5 times 0 plus 4. So your y-intercept is at 4. So it's just no matter what kind of function you have, if you're looking for x-intercepts, you set it to 0 and solve. If you're looking for y-intercepts, you put a 0 everywhere you see an x and then solve. And it's the same no matter what kind of function you have. Okay, so let me see. What was the other one I wanted to show you? Okay, so again, degree of the polynomial, you count the outside exponent. So 3 plus 1, because there's a 1 here. So this is a 4th degree. And then x-intercepts, you're going to go 0 equals x squared minus 36. And 0 equals x cubed plus 8, and that whole thing cubed. So you're going to solve for those. That's your x-intercepts. And then the y-intercepts, you just take both of these to 0 and then solve from there. Okay. You're gonna get into these and go, oh my gosh, what all did she say? All right. So this one, you're just looking at the graph. Okay. Look at your end behavior. See how the end behavior, this one is going up, up. Right? So you know it's an even. It's got to be even. They're asking for the minimum degree. Well, now you look at the turning points. So here's 1, 2, 3, 4, 5. So this is a minimum of a 6th degree polynomial. You just count the turning points and add 1. That tells you the minimum degree. Okay. And then the leading coefficient, is it positive or negative? Well, because they're both, the end behavior is both going up, it's got to be positive. Okay, so minimum degree, you look for the turning points. So remember the turning points is the exponent minus 1. So you're going to count the turning points and add 1, and that'll give you your minimum degree. Okay. Let me see. I wanted to take a look at the 2-word problems. Okay, so here's your 2-word problems, right? So this is taking us back to all those functions that we did. So remember, cost is your cost function is always the fixed plus the variable. Okay, so this one, they give us the fixed. They also give us total cost. So this is where you have to pay attention to what is it that they're giving you. What do each of the parts represent? And then they have a daily output of 20 boards. Okay, so you're going to find B, you're going to find the variable part. So you're going to solve, divide by 20, and is 290. Okay, so notice what they're asking for. They're asking for the cost function. So you have to do all of this first. You have to find out what your variable is. So the cost is the fixed plus the variable cost. Okay, so, and again, the X is the number of output, or the number of units per day. And then you'll use that to answer the next part. Any questions on that one? Make sure you notice what the variables are representing. That will really help you. Okay, and then this is another one. So it's just looking at it. It's down, down, which means it's got to be even. You have 1, 2, 3 turning points. So this has to be a 4th degree. So 3 plus 1. And then it's got to be negative because it's going down, down. Okay. Whew, I made it. Okay, so
Miss
when you,
Manchester?
yeah,
Oh,
go
sorry.
ahead. No, go ahead.
I just had a question. So when you say like you have to check if both arrows are like pointing up or down, what would it be if one was pointing up and the other was pointing down?
So then that means you would have an odd, you'd have an odd exponent, an odd degree polynomial. Let me see. I don't think they have one actually. Oh, there we go. Okay, so see how this one is one's going up, one's going up, and one's going down. So this tells you it's an odd, right? It's got to be an odd number, an odd exponent. So then you look at the turning point. So 1, 2, 3, 4, and then add 1. So it's going to be an x to the 5th power. And 5 is odd, so we know we're good there. And there's 4 turning points. So remember, the turning points is whatever the exponent minus 1. So that's why we add 1 to it.
So, but for when it like I had B, like if we had to answer B, would we just put odd? Or
No, the odd is the exponent. Then is the leading coefficient positive or negative? So since it's ending on a negative note, this is a negative exponent. Because remember, it goes up and then down. That's negative, or it goes down and then up, and that's a positive first term.
okay, thank you. I understand.
Okay. Anything else? Okay. So you have 2.3, which is homework 14. There's a little bit to it. So give yourself plenty of time to work through it. Okay. And like I said, I'm opening it up. So if you've already started on it, you'll have unlimited access now. So you can go back in and work on the ones that you got wrong. Okay. And I will change it right now before I forget, so that you have unlimited access. And then I'm going to do that for 2.4 also, just to give you guys some, because I know I went through this really fast today. So now you have unlimited access to be able to really make sure that you guys get the highest grades possible, because it's going to matter. As we're coming down to the end, it's going to matter. Okay. All right. Enjoy your wet weekend. It's supposed to be wet most of the weekend. We'll talk to you later.